Alright, so this is my second video on log properties. Here we're going to practice some of these problems. Please make sure that you note it's got to be a product to turn into addition, and it's got to be a division inside the log, not the division of two logs in order to be subtraction, okay? So we're going to practice some of these logs. I'm going to do some problems with you, and then we are going to move on. And then you can finish up the web work. And next week we will try solving, okay? So starting out, natural log of 1, 0. Why? Because e to the what power equals 1? Yeah, that's definitely going to be equal to 0. Okay? So that was one of our properties. Here, 0.01. Luckily, this log here is a common log. It's a base of 10. You can see there's nothing written down as a subscript, so it's understood to be a base of 10. And we could write this as 10 to the what power is equal to 0.01. Well, that's 10's hundredths. So 10 to the what power is equal to 1 over 100. What exponent is that? -2. Okay? For 3 and for 5, they're the same question here. But for 3, the e and the natural log are inverses. They cancel out. And this will just be equal to 2x plus 1. That is as long as 2x plus 1 is greater than 0. Okay, you have to be in the domain for that to work. Here, 10 log of 7 is just 7. All right, here the 10 and the log cancel out. Over here, we are going to use a property of logs in order to do this. This would be really great if it was just 10 log of something having to do with u. Well, we can use the power property and bring that exponent up there and attach it to the u, and now use our property that inverses will cancel out, and this is u to the -3rd. Of course, this is if u is greater than 0. All right. So there's just a few little practices. Now I want to talk to you guys about expanding logs. So how do we expand? Well, multiplication inside will expand to addition. Division is going to expand to subtraction. Right? And you can see in the directions, this is right in the terms of simpler logs. In other words, you have a complicated log here, and you want to write it as the, sum or difference of, easier, smaller logs, things that are not quite so complicated. And you can see these can actually get pretty complicated as we, move along with this topic. All right? So now, number 3. This is log base b of m to the 2/3 times n to the 2/3. I just distributed that exponent. Now we can expand log base b of m to the 2/3 plus log base b of n to the 2/3. And then finally we can drop the exponents down as coefficients. 2/3 log base b of m plus 2/3 log base b of n. Okay? Alright, so really quickly, I'm going to try and help you with this, some shortcuts, okay? So when we have a log that's as complicated as this in number 4, okay, we have multiple things in the numerator, multiple things in the denominator that are being multiplied, and so on. The way I think about it is anything in the numerator is going to be a positive log. Anything in the denominator will be a negative log. And any exponents will come out in front as coefficients. So this, right here for number 4, is going to expand to log base b of m plus log base b of n minus log base b of p minus log base b of q. Okay, now some people are going to say that, oh, this is multiplication, so it should be addition. But if you rewrite this as addition, you have to subtract the whole thing. So it would end up being like subtracting the whole thing with a plus. I don't tend to write it that way. I would distribute the negative and write it as you see here. Okay, taking a look at number 5. Again, numerator is going to be a positive log. The 1/3 is going to come out front. The denominator u to the 5th is going to be a negative log, and the 5 is going to come out in front. So I would write this as 1/3 log base b of v minus 5 log base b of u. Okay, so hopefully you get the idea with that. There are some problems in here where you are going to expand, and then you are going to substitute in various symbols or variables or what have you. Some textbooks would have you substitute in decimal values and things like that. So here, natural log of 7 over 3 is natural log of 7 minus natural log of 3. Your last step, just as your last step is in physics and science and so on, your last step is to substitute. This here is going to be hand minus smiley. Okay. Here, we have the 1/3 exponent, but 21 needs to split up into 3 times 7. So you're going to factor that. Then you've got the 1/3 exponent, which is going to be applied to both. And we can expand that. Oop. So this will be 1/3 natural log of 3 plus 1/3 natural log of 7, or 1/3 smiley plus 1/3 hand. Okay, so some of these are going to require some substitution as you expand. My last example here is going to be condensing. So I'm going to skip a couple of these problems. Here we go. Condensing. Now, positive logs means it's going to go on top, right? This 2 is going to come up here as an exponent. This is going to be log base b of, and that's going to be x squared, and the minus with the y means the y goes in the denominator. And so that is just going backwards, condensing logs. Here, log base b of m over n is going to be downstairs. This 1/2 is going to be your exponent. We could write that as a square root of n. Okay, so I'm going to post this worksheet up there. I'm going to post the answers that I have so far, and I'll post an answer key later on this week. Okay, hopefully this can help you get through the web work. Come by my office hours if you have any questions. Thanks.